So our first speaker today is Yogan from Tessolve Semiconductor, where he is the VP of Engineering. He has over 30 years of experience in the field of semiconductor tests. He is currently the Vice President of Engineering based out of Tessolve in Bangalore. He has been with Tessolve from 2004 and has taken several roles that include test engineering, R&D, and part of the hardware division as well. And the title of his talk today is System Level Test in the Era of Heterogeneous Integration. So over to you. Thank you, Yogan.
Thank you. Can everyone able to hear us? Hear
yes.
me?
Yeah, you're nice and clear. Thank you, Yogan.
Okay, and I hope you are able to see my screen as well, right?
Yes.
Yes, we are.
Okay, so I'm going to talk about first before we jump into system letters. I have put in some agenda here. So first, to understand the product development trends in the era of high performance compute. Then I'll go into the challenges from the test perspective. Then I will go into the system level test and the flow. If you look at the requirement in the industry, HPC is one of the area where a lot of development going in terms of heterogeneous integration. And the industry is able to accept the performance created, but they are also worried about the key factor, which is the carbon footprint, which includes electricity consumption, water, and the lifetime of the equipment. So if you are interested, you can go to the 8 Billion Trees website. They have told that 2% of the greenhouse gas emission is actually responsible by the data centers, which is a significant number. So when people develop a product, it's not just the performance, they need to look at these aspects. And all these throws into a challenge into the test, which I'll little cover later. Also, the solutions people are developing requires a domain-specific architecture based on the application requirement, like blockchain or machine learning. So no more common processor which can be used for many applications, but it requires a domain-specific application where the chiplet becomes a building block nowadays, which is no more a myth. It is a reality. People are really building a product based out of chiplets. You want to know a little bit more about the known good die integration? There is a video link I have given here. You can I've given a detailed talk. You can basically go and look at it. But the key aspect is like when you talk about chiplets, they can come from many different vendors, and when you integrate into the substrate is also a key element to becomes the critical performance of the system you build. And also the other area that we see is that the automotive industry is adapting to the newer process nodes, which usually known for well-matured process node will be accepted in terms of 68 nanometer. Now we know even 5 nanometer also goes into the industry like automotive, where the autonomous driving requirement it requires a heavy, faster compute, and those are all available in 5 nanometer or less. So it's a new trend, but at the same time, you need to really keep up the reliability what the automotive industry requires. And and you need to look at the thermal aspect also, where the TDP of these devices versus the operating temperature is a critical factor. And also just take the automotive thing. When you do hazard detection, it need to be communicated to the other network much faster. So 5G and other areas where are being adapted for C2X kind of environment, the latency is a key requirement, and for which the integration becomes even more complicated. So they are all, when I say complicated, they are all need to be tested for defects where sometimes the traditional AT may fail. Other aspect which is influencing the SoC product development is the standards, including the interfaces. BOW, BUC are the other consortium which defines the rules for integrating and developing such a heterogeneous product. Not to put aside the fiber optics is no more a separate thing. So you can look at, photonics is being integrated into a chip level for better, integration density and improvement in cost and power consumption. So co-optics is another area which is happening in the SoC product development. So what does it really mean? So carbon footprint is a very high level for us to understand. We are test guys, so we need to translate what it means. So every millivolt of power consumed by the device is going to save millions of dollars for the data center farms. And which means the substrate also need to be designed and optimized for the power delivery network, thermal management. And the industry is very interested in looking at the lifetime of the equipment. So there is a requirement for silicon monitoring is also coming into the picture of test. And when we develop the product faster using chiplets and other things, you need to look at the testability angle, which means a chiplet from 2-3 different vendors. If you put in and design a product, how do you going to ensure that you are able to achieve the similar fault coverage from the monolithic versus heterogeneous? So a concept of off-die DFT comes into picture. There are some standards do provide lane monitoring and other specification, but this is becoming a key thing. And when you have too many dies, traceability and security is becoming a key requirement as well. I'll go to the next thing, which is the challenges. So in order to put a robust test solution, when the product development cycle is fast, and we have to develop the solution much faster too, keeping the DPPM in mind. In monolithic, it is the DPPM number you design is what is going to guarantee for the customer. But if in the heterogeneous integration, it is individual DPPM counts and it becomes additive. So there is a kind of thing that you really need to look at. How do you test is a key thing that keeps always coming into mind, because you are doing a thermal insulation in a monolithic as an individual. Here your neighboring die in the heterogeneous will also influence, and the thermal management and your test time of defining a good or bad in ATs all in terms of seconds. Is it really good enough for such a high integration to determine pass or fail without replicating the real application scenario is a key thing as well. Which I think I had already talked about. The monitoring is a key thing in terms of voltage and temperature, so that you can monitor the performance. So your system need to be designed so that from the test perspective we can read those nodes, so that we can test by putting the workload, so that the power consumptions and the temperatures are monitored while we test. Traceability is a key thing in a sense, like since the heterogeneous package, you have so many dies from different vendors, let it be the 3D or 2.5D. Traceability is a key thing. No more a simple barcode will be enough. You need to have an electronic way of tracing what is inside. And the traceability requires in terms of automotive industries up to 15 years. If you have multiple dies from different vendors, in the say after 5 years you want to find out, nobody will have a data. So something has to be put inside the die itself, which so that any root cause of any issues due to RMA can be diagnosed faster. There are some standards from SEMI, but it is not addressing fully. So there is some area of work need to be taken in the terms of traceability aspect. I talked about the lifetime of the equipment. So monitoring is a key thing, especially when you go to nodes much smaller. The silicon monitoring is a key thing where aging effect could delay the affect the propagation delay and hence the product performance. So there are softwares available from the EDA tool vendor. We can implement the silicon monitoring. So for as a part of test, we need to implement this so that during the life cycle we can read this signature to tell whether the device is aging and whether it is reaching the end of life or not. I will now given a big picture of the complex things that comes into test from the product development and the test perspective. Now I go into the system level test definition. System level test is an ability to test a chip or a multiple chip in a pack in the context how you will ultimately test it. Which in the AT base you test few blocks and tell it's a pass or fail. Whereas in the system level test, it is not so. In other words, in a system, when you put a product, it actually works with few other support ICs, which are not a product from this same vendor. It could be from any other vendor, for example, PMIC, external memory, and all that. But as a system, if it has to work, it really need to work with the other support chips and also the firmware required to run. So what it means is you really need to understand the customer specific use case, which has become the key thing, so that you run the test cases based on the actual use cases, so that there are chances that catching failures like silent data corruptions, which are not easy to capture. But by these methods, there are possibilities that you can increase the DPPM and the quality requirement. So these are the situations which drives the need for system level test. And also, if you look at in the system level test versus ATE, in ATE you do like 4 or 8 devices in max in parallel for very high pin count device, and you basically complete the test within 10 seconds or not more than a minute, I would say. Whereas in system level test, you basically actually run the actual use case, which means it will be running on the OS which is supposed to run, and it will be running the interface test and workload that you want to put in. So, and it can take in minutes or in terms of hours too in some cases. So this requires a really massive infrastructure of tested in parallel to meet the cost of test economics. And such equipment may be common for a bigger processor industry like Intel or AMD, but other industries who's developing a solution, there is a additional capex is required. So this is something need to be noted. I will go into the next aspect, which is the flow, which means if you, in the heterogeneous integration, if you have like 3 different chiplets, they all need to be tested, of course, and most likely they are tested for structural aspect and some performance aspect in terms of functionality using low-cost ATE, and they are tested in like maybe 8 devices in parallel. Then if you put a heterogeneous integration, the package substrate performance also influences, which means the functionality of an individual die no more guaranteed in the package level because of some of these influences, where it becomes a bigger product. So hence it is really essential to put this product in a way it will be tested in the system, for which you need a infrastructure of high parallelism SLT handler, and a solution need to be created catering the OEM's requirement, so that the end customer's use case are run. And sometimes the people are saying that after SLT they want to make sure they are little confident on the test, so they run some simple power consumption continuity test on ATE before they ship to the customer. So in summary, you really need a deep embedded product development cycle experience to develop a system level test solutions. And the typical ATE guy may not be able to create such unless he gathers a new expertise. So and also you need expertise on developing the use case test in popular OS like Linux and Android or things like that. And most importantly, you really need a solid SLT handler partner to develop a robust system level test. And this is the summary I want to convey in today's evening. Thank you.
Hi, thank you, Yogan. We have 3 minutes left, so there is one question. Have you got any examples of where you've used system level test? Please?
Well, definitely, HPC kind of device are the one need to put in, and devices that may go into, automotive where it does a heavy graphics compute, such kind of, where the decision has to be taken faster and accurate. Those are all things we cannot take risk. Any mission critical applications that are required definitely need to go through system level test.
Okay, and did you have any examples of issues that were found a system level test level that weren't found at a individual device level test, other traditional test equipment.
Yeah. I was in a meeting with some customers they have told that a processor tested in ATE put on into the customer thing didn't even not boot. So, various reasons, right? So they are all adapting to put, it's very difficult to why and why not. So such situations are need to provide us a system level test. This is one example, the customer told frankly that, they just want to boot the device and measure some current and, things like that before they want to send the chip out to the customers.
Okay, and they do that in an SLT context. Yeah.
Yes.
Okay. Okay, no more questions from our audience. So thank you very much. Thank you, Yogan. That's a great introduction.